thank you everybody for coming. I think it's just way too much of you here. I don't know why you're in here. If you don't know what it's about cubes. So, the session it's hip to be square, right? So if you're feeling now you're in the wrong room, which I just think like 50% of you are, then, that is now the time to leave. Damn it. All right. Okay, just quick introduction. With me here is Paul. Paul is a very lucky Englishman, whether, he actually does not care about football at all. He's still, like, in the last second, like, yes! Even though probably he's English.
And Lennart, as well as knowing everything there is to know about cubes and OLAP, is also a very unlucky German who's here in the middle of the World Cup. And go easy on him, try not to...
Please.
Try not to... So we've picked a wonderful topic for this talk. Given the time and my co-presenter. We're basing it on football. We're kind of basing it on football. It's actually originally hockey. It was run out of the US, but nobody here cares about hockey, especially at the moment. So just kind of squint and it'll be football. So as you can tell, we've kept the same structure from the hockey session, but cunningly tweaked for football. So the first half, we're going to be talking about how Tableau works with OLAP in general. We're going to do a quick sort of demo running through the various differences in navigation, the different metadata and blending options that we have, and then talk a little bit about OLAP in the wild. I believe we're going to be giving all of these slides via the download link when you get back from conference. So feel free to record if you want, but you'll get the content. We'll then move on to a demo talking about some of the specific kind of MDX calculated member options and the Tableau equivalents and how we can work with both of those. And then just a little bit of sort of general kind of what you need to know, best practice sort of information about OLAP with Tableau, and we'll wrap up in the third half. So hopefully learning goals should be fairly clear, meet your expectations. You're going to learn how Tableau works with cubes, what you can and cannot do, what the differences are, and how we can enhance kind of normal cube usage with some of the things that Tableau does a little bit better, hopefully. Okay, so let's get started with... Wayne Gretzky said something about hockey once. I wasn't listening. So OLAP or Tableau. OLAP was devised, or kind of the core concepts were set down by Edgar Frank Codd, and he said that there should be 12 rules for online analytical processing. And if we look down his 12 rules, I don't need to read them all out, but they basically kind of align with what Tableau does anyway, natively, naturally on relational sources. So this kind of question comes, why would you use OLAP? Has technology advanced to the point now where it's no longer necessary? When it was originally prescribed, the idea was to take very limited processing power, efficiency of storage, and kind of make do with what they had while still providing a kind of rapid, fast slice and dice approach to data analytics. If we can do all of that now without having to go to the effort of building and structuring data into a cube, why do we still see people using cubes at all? Well, you can kind of just merge, the two of those into Tableau. If you've got cubes already in your environment, there's no need to kind of tear them apart, start rebuilding all of that work that's been done already in Tableau. You can use the same user interface with some small variations that we'll go into to present the data regardless of the source that it sits on. So the aim here is to just kind of present a unified view of data from whatever the source may be. So yeah, a lot of the things that you can do in Tableau are going to be pretty equivalent to what you can do in the OLAP world. There are a few things that change. So blending, it's going to be slightly different. We have different calculation options. Calculated members come into play, so we can kind of enhance cube structures a little bit. That's kind of worrying. Asymmetric reports we'll go into. I'm not going to explain what that is until we see them. And hierarchy filters are something that we inherit from cube structures, which are actually quite nice. That provides quite a sort of lean way to analyze hierarchical data that's in some ways better than the way Tableau natively does it on relational. Okay, so let's get into the first of that. Pass it over to my beautiful assistant.
Thank you so much, Paul. And beforehand, there are a couple of seats over there as well, free. So if you don't want to stand or anything, there are still a couple of seats over there, free. All right, let's get into the nitty-gritty of things. And the first question for you all is, what are you actually using? So I'm, asking in terms of percentage, like analysis services. Who's using analysis services? All right. Who's using Essbase? Okay. Teradata? All right. BW? Okay, so I guess we have like an MSAS, BW, Essbase, Oracle shift to the things. Anything else? Anything else you want to come up with? We'll just Power Pivot, but don't care. But anything else? Anything exotic? Well, yeah. we don't talk about that. All right, cool. Okay, what we're having here is actually an MSAS cube, kind of local, but that is just the easiest way to show you things which will not work in anything else. So, we can show what is cool, and then you go home and nothing works what we showed here. That is actually the thing, how we're trying to do things here. In the lower left or lower right, just a quick thing I have to check. Oh yeah, that works, cool. Good one. All right, so we have here on the left, your dimensions and your measures. One thing that's working for MSIS and for a couple of other things is that we have dimensions in here and hierarchies, right? So here on the left, for example, you can see a hierarchy. That is the bond geography, and we can actually change that. Now these are elements in the hierarchy. We can actually change them to a geographic role. So for example, say that here the city, that should be a city as well, right? Easy enough. But you also have right here the city again, like as another dimension that is not within the hierarchy, right? And in here that Tableau already picked up that this is the geographic role of a city. Well, easy enough with that name, right? So Tableau tends to find things that has the right name and put the right geographic role on top of it. So that works quite well so far. Right? Another hierarchy is here, for example, Teams hierarchy. And let's have a little bit of a look, what is going on with them. We can actually see, right, so for every member of the hierarchy, we also have a dimension, within our, Teams folder here. All right, so let's have a look what is going on with Teams. So we have some couple of goals. We have our teams, right? All right, first thing we notice, we're going from the Anaheim Ducks to the Winnipeg Jets, whatever they are, nobody knows, nobody cares, but from Anaheim Ducks to the Winnipeg Jets, that is all sorted alphabetically, right? Same thing with the hierarchy here, with the hierarchy of team. That looks different, from the Boston Burns to the Vancouver Canucks or something, Vancouver Canucks. So that's not sorted alphabetically. How is it sorted? Well, let's find out. We can, hover over that and actually see, well, I will zoom a little bit in, we can see, that is a hierarchy. And we can actually go up all the way through the hierarchy, all the different levels that we're having here, from the conference to the league. And then, of course, as you know in a hierarchy, as you know it from a relational way, right, then just, move through the hierarchy however we want that. And that, what you see now, is again, the same sorting for the teams. So the sorting of the last member in the hierarchy is based off a sorting within the hierarchy, right? So if you need anything to change there, you've got to go back to your cube master and ask, well, can you change something to sorting within the hierarchy to have different sorting here? Because you cannot change it in Tableau as you know it maybe from relational data sources. All right. So one other cool thing, that works in here, which just enhances, how we work with cubes, and which is just the same way as we would use with relational data sources, is that we can use, for example, here for our team, we can set default properties, right? Like colors, like shapes, right? So, making it very visual, making like appealing for the people that are then, using this data source or which are using then the report. So we can just, for example, just now have, let's say, goals 2 times, right? Let's combine these two to dual axis. That all looks weird, but bear with me. There's a bar, having some colors. So that's now all the colors from the different teams, their official colors, because we can actually have under the default properties, right? Get in there, real colors, get in the custom color palettes that you can set up in Tableau, as well as maybe, right, custom shapes right here, because we can also set under the default properties all the different shapes of all the different teams. So out of a sudden, that doesn't look like a boring cube anymore. Did I say boring? But it looks actually like something that you can do with Tableau and how Tableau can actually enhance, your work with, with the cube data. Also something that works, like as it does in the relational world when we connect to a relational data source. All right, let's look a bit further because, well, how does it all look with filters? Well, let's have our teams in there, let's have some goals in there, and let's just, find out how it works with filters. So just, right-click on one, exclude, easy enough, same way as in relational, nothing new here, right? We could have even go ahead, choose some of them, create a set, right? So we can create a set, from a dimension here, as you know it in the relational world, and actually, here in the lower left, we could combine these sets together with each other, just so we know from the relational world, combine sets, inner left, and something like that. But when I want to use that set, and I actually drag it onto filter, you maybe know from relational world, you can have, a set can be an in or out, right? I want to see all the different things that are within the set, or all the things that are not in the set, right? That's not working in the cube world. It only works as an in filter, right? So that's the only thing you can do with that actually. All right, but beside that, works as in relational. But what happens if I'm not filtering on the same dimension? That's the easy one, but maybe I want to filter on something else, for example, on the positions of players. Right, so here we have a couple of positions, don't really worry about what it is. Let's say C stands for center, and I want to see all the different goals from all the teams, from the players that are playing in a central role. Right, so I'm hitting all of them, click OK, and there you see one major change. There is a sigma sign, some sign going on. When we actually go ahead, look into the filter, not adding it to context, but actually showing the filter, right? We can go ahead, lose all the different filters again, only till we have the C, and then you can see there's no sigma sign, because there is actually intersection between teams and people that are playing in the center, between one of them, right? Between one team and one of the players that are playing in the center. So therefore we can get a number of goals for that intersection right from the cube. But as soon as we want more, right? So as soon as we want to have all the center guys and all the center which are also playing on the left wing and all the center guys which are also playing on the right wing, Tableau has to do the aggregation for you because there is no intersection within the cube where we just can grab the number from. Right? So Tableau has to do that. So that can maybe have some implications on how does actually the aggregation there end up? What is this number? How is it aggregated? Is it actually all right to just sum it up? Is that the right way to calculate the number for different filters here? That's something that you have to keep in mind when working with filters and working with cubes. All right. So filter on one dimension, kind of boring. Let's move over to the hierarchies. That are way more, they're way more thrilling, I would say. So let's get into it. Let's have a hierarchy here. Let's have our goals. We have the National Hockey League. We have all the conferences, Eastern and Western. You maybe know that from the Americas. we have different divisions, and again, like the different teams, right? Cool thing. And that's actually something that a lot of people also want, like for the relational world. I can just like click here on Metropolitan, and there is this little plus sign here, right? And that is actually what Paul said earlier about asymmetric filters. Now, we can only filter in, only look into the division of Metropolitan Area, right? And not see anything else. That is something that's not working in the relational world, but something that is actually kind of cool. All right, I can also have like the division here on color to maybe have a better understanding. All right, but what actually goes on? So let's look into the filter, and I have to make it a little bit bigger here in order for you guys to see something. All right, so what does actually happen? So we have now like Metropolitan Area open, and we can see two things. Metropolitan Area is the only one that we have open, right? And we have here like set a check mark on Atlantic, right? So that is one division. We have not have a check mark on Metropolitan, but on all the different teams within the Metropolitan Area. Right, let's have a look how that looks when I go back from Metropolitan, make it small again, right? So in here, again, this time Metropolitan is selected, Atlantic again, but none of the teams. So that's how you can change around with the filter, play around with the filters, and of course, play around like with this filter here as well, on the right side. So I can check Metropolitan, but I could also check like a couple of teams. That would sum me up all the goals for the Metropolitan Area, but still show me the goals only of like a couple of specific teams. And I could also use these little hierarchy levels here at the top. So from my perspective, it's coded a little bit confusingly because it's from 0 to 3, whereas you have here on the left side from 1 to 4, but forget about that. So what you can do is actually select and deselect all of that, right? And for example, now select, I only now have all the teams, right? So I'm on a deepest level. Let's go one level up, right? So I'm now on the second level, which is the division level. Now I have all the divisions in there. Now maybe I want to have all the conferences in there, and maybe I want to have all the league in there as well, right? And then I can of course play around with all of them, have a couple of them in there, a couple of them not, whatever feel like is necessary for my analysis. But this gives me way more flexibility, for hierarchies than you have in the relational world when you build a hierarchy, on a relational database in Tableau. So that is kind of cool. All right, next thing that works kind of as in the relational world are totals. We can just drag and drop them, totals, easy peasy. It's the same, at least how do we create them, but there is a difference on how they are calculated. So please see here, I will actually zoom in a little bit, right? We have a grand total. That's one you should keep your eyes on. Like the grand total, 3,625, right? There are also a lot of other subtotals which are the same, at least with the two above. So what happens when I now get out one of these teams, right? So Boston Bruins, I don't want to see them. The Buffalo Sabres and Detroit Red Wings, don't want to see them. You can see that the grand total itself is still the same, right? Even though I excluded a couple of teams, but the subtotals changed. So why is it happening? Because the grand total is calculated on the highest possible hierarchy level. And because I still have, like the Eastern right here, right? I still have Eastern right here, that is calculated on Eastern. When actually Eastern, there are still 3,600 goals in there. So in order to then get a proper, or maybe the grand total I want, I have to deselect Eastern, and now you can see that again all the subtotals align with the grand total, because the grand total again is calculated on the highest hierarchy level that's possible, right? If I have it in the view, if I have it selected. All right. So blending, Paul already introduced a little bit of blending. So what is possible in there. So let's have a look. We again, goals are always great, and maybe not conceding goals in the after time. That would be also great. So how do we blend? Well, we have a cube. We have as another file, we have an Excel data source, easy enough. And in here we have team codes. I will just zoom in a little bit. So we have team code. This is the one we're using. And just as in a relational world, you see that little, what's it called in English? The little blend thingy.
Oh, like chain link.
The chain link. Do you use chain link for? Yeah. All right. That's the chain link. Oh, I learned something today. Cool. So the chain link. We use chain link. Cool. It's the same as in the relational world. So I will try to use the team code on rows, and ta-da, nothing works, right? Because we have to set up the relation for that. So click on the chain link, easy peasy. There we go with our blend. But one thing that doesn't work with blends, well, there are a lot of things that just by default doesn't work with blends, right? But one thing that doesn't work with blends in cubes is sorting, right? So if I now want to see, so maybe, I want to have like an average line in here. So now I have the average, how many goals has each team scored within the time set we have here, right? And I want to maybe sort them on what was the best team and when did the teams then derive from the average. Kind of hard to do right here because on a blended dimension we cannot sort. Good thing there's a quick way around that. And just the easiest way would be to actually create a new calculated field. I would just call that blended field, and we will go into that how we use calculations, what is possible with them in a later stage, in a later demo. But just bear with me here. So I want to use the team code within a field that I created in the cube, right? So that's actually the only way how you can use dimensions within calculations in cubes. But that's another story. All right, so I have now a blended field in a calculated field in the cube. Just have to click OK. The blended field is now here, down here, under measures, because we can only create measures within the cube. And I can set it up, pick it to rows, have the team code and details. And then out of a sudden, when I maybe exclude the null, out of a sudden, right, I have the sorting. And I can actually sort. And that is how you work your way around the little things that doesn't work with cubes. All right, putting it all together, right? So that could be something that is maybe hard to build. So build that in Excel. I challenge you, do that. That is something that you can do, and how you can maybe leverage what you can do with Tableau on top of cubes, right? But there's just one more thing that is different to the relational world that you will experience in the cube world. And that is, we see, so earlier, right, we set default values for team, right? So like color and shape. And in here we can see a lot of teams, right? A lot of teams with their, special emblems, with their special colors. But we could also see, well, that is here, only the division, right? And still, that got a shape for it, so that's the Boston Bruins as well, and that are actually the colors of the Boston Bruins, right? So when we are not on the deepest level where we set up our shapes and colors, it just takes the first entry, for whatever comes below it, right? So that's why that is the Boston Bruins symbol and the Boston Bruins colors. It just takes the first one, and actually, we just go ahead and here. Open up like the shape pane here, the shape marks, and then we can get onto shapes. And you can see here, this is called ragged. Ragged. I learned that, it's ragged. All right, it's a ragged. And you can just change it around to anything else. Let's have it like a bug. I don't know. Right, so you can have it like that, and then you can use here like the color palette. So let's give it a great color, something like that. All right, well, if that isn't great, I don't know. But that's again how you get your way around. Like you set something up. There is something happening that you won't expect because you're not maybe used to that in the relational world, and that's your way how you get around that. All right. So now I got to move quite quickly to that and that. Does it work? Cool. All right, so quick wrap up of what we just learned, right? So on the left side, what is working like it would be in the relational world, and what is maybe more, what works differently when we work with cubes. So sorting of attributes, just attributes, just dimensions actually, just by default, that works like in the relational world, right? Sorting of hierarchies doesn't, right? Then you have to go back to your cube master and ask master, please change the cube. Default settings, right? Just very usual stuff that you know from relational world. That also works in the cube world. That's already great. But I have not gone into that, but actually changing the data type. So, for example, on a hierarchy, you can only change the geographical role, right? You cannot change the hierarchy to a date, to a string, to a decimal value, right? That is set. We can change other dimensions, so the other dimensions that are not a hierarchy, you can change them around a little bit, but that is only because we are actually using here MSIS. Filtering dimensions works just like you're used to, and but when you're actually when you're filtering, the measures will be calculated if you're not having like an intersection between all the different filter values that you put into it. Right? Creating and combining sets just works like in the relational world, but it's actually only an in-filter. Right? So this is the only use for it, whereas in the relational world you could do way more with that. You can have, which is great in the cube world, like the filtering hierarchies, the asymmetric filters, asymmetric hierarchies, all of that. That is something great that you do not have in the relational world, which is like a plus for the cube world for all the downsides. You have your totals, right? That works. But how the totals are actually calculated is something different than the relational world. Just keep that in mind. Sorting on blended fields, that just does not work. You have to have a workaround for that, right? And the ragged use, just have to keep in mind that, whatever you do in your hierarchy, you can end up with a ragged that you have to, play for, have to, think about. All right, with that, we're actually going to more theory, and there comes a theory master. Thank you.
Let's just move that out of the way. Oh, it's collapsing. Okay, so yeah, a lot of that is, the subtle differences, right? But there's nothing necessarily massively compelling that would drive you to choosing to use a cube over a relational source. The decision doesn't really come from the Tableau side at that point, I think. So what are the main drivers that we have for seeing customers still using OLAP in the wild? Actually, probably one of the biggest is the idea that they want kind of a single version of the truth. When you've closely structured, carefully prepared, pre-aggregated and calculated everything into a cube where you don't have as much flexibility as you would be giving people, you kind of get a little bit of confidence in the numbers that come out of that. That's why also Tableau is quite careful to throw the sigma sign up when it's doing a calculation on your behalf, so that you're aware that those numbers are not necessarily directly replicated from the cube, but we've done something to them. You can watch for that because some aggregation types might not lend themselves to being summed. So yeah, a lot of customers still like to keep their cubes in place because they trust them. There's also, potentially out there not just Tableau in play. So there's going to be a lot of customers. Every customer uses Excel. A lot of customers maybe have SAP BI or using SQL Server, something which is going to be accessing these cubes anyway. So they want to make sure that for consistency's sake, when Tableau is reporting on something that's also being reported out of in other business units, maybe using different tools, that they get consistent responses. Yeah, so the other thing about like pre-building the model and keeping it closely structured and everything is the amount of complexity you can build into that at the design stage is high in cubes. Tableau, has its own data integration that can cope with, very many business use cases. But if you want to have a single container which is performant and which accommodates a lot of different relationships and a lot of different navigation pathways, often navigating star schemas and snowflake schemas is still a good use case for a cube. A lot of cube modeling tools can automatically interpret even and build out, well, a lot of the good ones, not necessarily like SQL Server, also things like many-to-many relationships, we can accommodate those in Tableau on relational. You can work with mapping tables and things, but cubes can actually just kind of rationalize those into pre-aggregated data stores very quickly. And sort of the origin, I guess, of cubes was this need for very large amounts of data to respond very quickly. We still do see, especially in big data kind of landscape, aggregation is a lot of the time that's spent in any reporting from the database side. So having those pre-aggregated values, I mean, there's ways around that in relational as well, but a cube is by definition almost dense and compact. It saves a lot of time. It preloads the time in cube generation that you would otherwise be spending waiting at report execution. We do see cubes quite a lot in the financial world as well, financial reporting. I think a lot of that is just due to the very hierarchical nature of the balance sheet sort of approach, and we just got a couple of screenshots of how you would build that in different tools. But cubes are still used, I think, was it TM1 you said at the back? Cubes with write back, very commonly used in planning and other financial consolidation. But even more static cubes where you build it once, it works very nicely for a lot of financial slice and dice use cases. And you've seen how hierarchies behave differently. I think that the hierarchy filter support that we have in Tableau works very, very nicely for cube data sources. Cubes support natively some hierarchy designs which are extremely hard to build in Tableau on relational, actually. So unbalanced and ragged hierarchies, unbalanced being a hierarchy where you have different sort of premature termination of levels. So some branches of the tree end at level 1, some branches end at level 3, and you're never quite sure how far down you can drill before you hit the root node. Or ragged hierarchies where you might have just missing levels in the, we might be missing this level altogether and it jumps straight from the top tier to level 0 without having a level 1 in the middle. Those things are quite hard to do. You have a lot of calculations involved in doing that on relational, but cube support tends to just be built around the idea of a parent-child hierarchy, which completely sort of bypasses any of those challenges and gives you a direct drill path. So being able to interrogate those in Tableau is quite useful as well. Another thing that we see quite a lot in cubes still is just the ability to have aliases, not like Tableau aliases where it's just a single kind of translation from what is in the source to what you want to call it, but varying different options. You might have a technical name, a long name, a medium name, and then names in various different languages, which are all just stored as attributes of the member. So you can choose which of those variants you want to see in your report. That's something which, again, is more of a data modeling exercise and relational than it is just navigating the cube. Okay, answer. I'm actually going to turn this off, I think.
I got to do stuff again. Okay. Cool. All right. Then do this one. All right. So let's move into it again. To Tableau. This time I have no question actually. Now we will look into dates. Date is something that always messes things up, except especially in cubes. So let's look how, Tableau behaves with dates in a cube, right? So we have here a great hierarchy, right? We have a year, we have a couple of goals again, right? We can move, like it's a hierarchy, we can move through that. But if you're maybe used to the relational model, you would now, at least now expect a line chart, wouldn't you? Right? But you don't get it. Because a date, even though it is, it is a date in a cube, right? Tableau doesn't understand a date in a cube. Tableau makes out of that a string field. Right? So therefore, Tableau doesn't really understand the date that is coming from the cube and just puts in strings instead. So therefore, it is kind of hard to work with dates and cubes and Tableau. When we, for example, go ahead, get the year out, get the date out, you can see here, when we move over here, right, something we have seen earlier, right, that is the, they are getting then sorted alphabetically, right? So we have here April 2017, and right after that, of course, December 2016, because that makes sense. Right, then it's just because of the naming for the months. So actually, you would go to your cube master. I still call him master, and ask, please, master, change the naming of the months in my cube if you want to work with that, right? And then you would, change the naming, for example, to year, month, day, or something like that, and then you would have like the proper alphabetical sort that also tends to be like any like date sorting. All right, or we try to get a continuous date to work with, Tableau. And actually, we have here like the date short, right? And the date short, I'll just, put it on here. You can see that looks like a proper date, right? And that is actually something Tableau should understand because, well, if you know from the relational world, Tableau tends to, just pick up, your date format and put it into like the proper Tableau date format. And it actually works this here as well. We can go ahead on date short and actually change the data type to date because we are in the Microsoft world. So that tends to be easy. So we have a date short, we have our goals, right? There we go, easy peasy. We can even have a trend line in here as well. So that works out. What doesn't work out? Well, it's still not a hierarchy how you would expect it to be from relational world. So the proper date hierarchy, we are now on the daily level. But you maybe want to be on a monthly level. You want to be on the yearly level. You want to be on a weekday. You want to be on the week level or something, right? Well, too bad. So, but maybe, no, not maybe, but we can use that, for example, to use as filters. So that is quite cool. That is something we can make use of and use this as a filter. So, right, make it like a little bit smaller, like this. Right, and use this field, so the continuous date, as a filter when we again, like for example, use our year and use our month, right, and a different date, and then we can move around through our date hierarchy with this continuous date filter, which is kind of cool, but only because we cannot do anything else. That's why it's cool. But maybe, right, I'm only showing you the easy stuff, right? Maybe there is a way we can do better. Is there, Paul? Is there?
Let's take a look. Turn that off. I'm not tall enough for this mic though, so I'm not sure how this is going to work. Right. Where are we? Continue to stay down, guys. Yes. So can we have the? Yes. Can we just leave it on this one for the? Because I'll be at the podium. Thanks. Yeah. So. The other option that we have available to us on a cube source is MDX. Unlike relational sources using SQL for their language, we deal with MDX when we're working with cubes. And we do have the option in Tableau to write MDX expressions directly into what we call calculated members. So if I open up I'll just do that again, and I will actually zoom in so you can see what I'm... There we go. So we've got that calculated members box there, which is new if you've never been using cubes before. And that opens up a very different calculation editor to what we have traditionally. And what it allows us to do is specify MDX functions which we are going to integrate and send with the MDX that we automatically generate. So this one here, MDX date continuous, uses an MDX function which is supported by some MDX data sources. On SSAS Cube that we are here, we can use this. You would have less luck trying to use this on BW because they didn't bother to implement it. But CDate, and then here we have the day unique identifier. So time.dateDay is the unique identifier for that day dimension. And then we ask for the current member and the member value of that member. So as we're breaking down through the list of returned results, each of those members we can find out what that value was, pass it into the CDate function, and we'll be returned an actual date, which we can see. Again, it's still just a static continuous date at the lowest level, but it's functioning and it'll work the same way as the previous example.
Cool. So, all right, next thing there would be is, no, maybe you catch drift now. We are talking about calculations right now, and I will show you the easy way, and Paul will show you the not easy way. So, next thing, scorer points, right? So we have guys who are shooting massive goals in the Premier League. So 30 goals from Conor McDavid, who doesn't know him, and like 70 assists. That's something great. Scorer points, of course, they are consisting of goals, right? I'll just zoom in your goals. That isn't wrong, all wrong here on this keyboard. Goals plus assists, easy peasy. And there we have our scorer points, like of 100. Easy enough, right? In a typical calculation, in a Tableau calculation, we can use measures only. And we can only create measures. Right? We cannot use any dimensions from the dimensions pane. Right? So that is like a big caveat, but for that type of work, if you ever come across calculating like scorer points, that is easy enough. Would that be something that you could also do in MDX, Paul?
Would. Yes, it would. So, you may have noticed that absolutely nothing has changed as I switched over to that tab. But the way that we're getting there is different. So we have this MDX points measure, which has been written already, because writing MDX in front of a crowd is just fraught with danger. But it's actually quite simple, this one. So, again, we're just using the identifiers for the position in the cube structure. So measures is the measures dimension. Most cubes implement a measures dimension that they store all of their key figures or measures in. And then point goals, and then we add to that measures dot assists. And this is calculated then, again, in the MDX. It's equivalent to kind of pushing it down to the source system, the way we would do it in a relational calculation.
That's already it?
That is already it.
You could have written that.
On that one.
You could have written that. Okay, next stuff we're going to talk about is table calculations, if that isn't exciting, table calculations. So whom of you is proficient in table calculations? Quick show of hands. Easy peasy table calcs? So, okay, a couple of small hands going. All right, okay, cool. So I'm not going into that deeply because, well, that is maybe my job to know about that. Table calculations are just like a quick way to calculate, different stuff on different aggregation levels, on different levels, very quickly in Tableau without really writing a big-ass calculation on your own. Right? It's a very easy way, especially with the quick table calculations, to get to a calculation where you're going to, but it's all depending on the view you're having, right? So in here we already have it all done. Like we have all the different teams, we have the different goals, and for example, when I drag down here, I get the sum of Atlantic in the lower part right here. We can see that's 1,700 goals have been scored, right? And actually, right here, there is a table calculation for that shows us these 1,700 goals for the division of the Atlantic. All right, so that is a very easy table calc. Also with percentage of goals within the division, right? All the goals that have been done in the conference, so all of these add up to 3,600. That's a number we are familiar with, right? We have seen it earlier. All of that adds up to 6,300, which is just the goals, the amount of goals for the conference, and then again, like the percentage of all the goals that have been done within the conference. Easy peasy. We can just have a quick look in here and see what is actually been calculated, kind of edit calculation, and you can see all the different things on how to set up your table calculation in order to actually get to your value. All of that works like in the relational model, nothing new here. It's just very awesome that table calculations actually work. Well, do they work? Because I really don't care about division. Let's get it out of here. And suddenly nothing works anymore, right? Because it's all dependent on how you set it up within the view. So the question would now be, is there a better, more flexible, more robust way to do that? Is there, Paul?
If you're familiar with Tableau, you might be thinking that a level of detail would be the way to do that. And that's the exact opposite to the way I was thinking when I joined Tableau just over 2 years ago. I came here with OLAP in mind and spent many hours trying to solve what should have been a relatively trivial problem using an LOD, because I didn't know LODs existed. And I went looking for a function called ancestors, which I was familiar with from the OLAP world. And I wasn't on OLAP, so it didn't exist, and we couldn't do anything like that. But LODs were the Tableau implementation. Well, when I'm working on a cube, it's kind of nice. I actually get my ancestors function back. So if I just go and have a look at our calculated members again, we can see that we're working here. Zoom in for you. Using that ancestor function. So what we're doing here is navigating the cube's hierarchy. So we're taking a tuple of the goals with the ancestors of the team at the division level. Let's kind of walk you through that again. The goal is the measure that we want to combine. We've got the ancestors.
Paul, you should put on your microphone then.
You can hear me at the back, I think. Okay. I don't know. So yeah, the team here, the current member, again, as we go down this list of members, that kind of tracks your position. And for each of those, we look at the level, the ancestors, at the level of the division. The nice thing about that is we can also do that at the level of the conference, just going up 2 levels in this instance. We're not naming it. And so we have exactly the same kind of structure here, but if I decide to drop division, then it doesn't break. So that's 1 point on the board for OLAP, I think.
So 10-2. All right.
Yeah.
Cool. Maybe you get one more, maybe. So let's talk about grouping. Grouping is something great you can do in Tableau in the relational world, right? So for example, we have seen here again our positions of players, right? So let's imagine, beforehand, we, for example, put a filter in to see what are all the goals that people that are playing in the center, right, have done, right? But maybe I want to have only people that are in center grouped together. Something very easy when you work with Tableau in the relational world. You would just select everything that has a C, for example, in it, or at the start, or wherever. Well, it's up to you. And then you would wait for the pop-up, and then you would click on the grouping button. Well, if you find it, because it's not there for the OLAP world. So no groups for you, that are doing OLAP, but maybe there's a better way.
Maybe.
Is there, Paul?
Of course there is. It's almost like we've set this up ahead of time. So yeah, again, using MDX. And we have here somewhere MDX position. Where are we? MDX position. That's the one. So MDX position calc that we're doing here, we're using something that's a little bit kind of cheaty actually. We're just taking the leftmost character from the member name. So if we look at that, oh, we have that already. Of course, yeah. 1 second. Position. Okay, so if we break it out by position, we can see what we're doing here. It's kind of a cheat. We are just taking the leftmost character, so where the first character is C, then it works for center. Where the first character is D, it works for defensive, I think, and then left and right. But obviously, if you're trying to find out which is a player who plays in the center, not necessarily his primary position is center, then that kind of breaks down. So to do that, we might want to get a little bit more creative. So we've got here an aggregation now of center, left wing, defense, and right wing. And we've done that by actually creating entirely new members and inserting them into that dimension. So if we look at just one of those, the center, we can see here that we have the individual player positions have been concatenated, essentially, well, added together, not concatenated, summed. And then we are inserting that as a new member, which we name center, so we can call that whatever we want, and we're placing that directly into the players.position hierarchy that exists in the cube. We're not specifying a level here because it's a pretty shallow hierarchy. And if we look at that, you end up with a little bit of double counting in a way because actually purposefully we get some double counting because now center contains everybody who could play in the center. Left wing contains everybody who could play in the left wing, but some of those players are being counted in each of these positions. But we also get the raw positions that are stored in the cube themselves. So if we want to filter that out, we've just defined some sets here which allow us to go for only the cube. Or if I go to the positions from MDX, we can filter down to only those positions which we've generated. And if you want to find out how to do this kind of calculation, we need to know what that name is, right? We need to know what it's called in the cube, in its identifier. Well, we can do that just using a simple function where we get the unique name of the current member. Again, that's an MDX function. And that will return, instead of the caption, which is the human readable form, we can just use that in a table to show us what that is referred to internally in the cube structure. Okay.
All right, and with that, bop, bop, and bop. So, quick, wrap up again. What have we actually learned? All right, so what on the left side works, what works, as you know it, and what could be MDX magic. So, changing dimension to date type and using it as a continuous field, that works, or as a filter, that works, but there is no built-in hierarchy, there are no other filter options that you have seen, like this year, for example, not there. that is all MDX magic. Because with the CDate function, all the other functions, you can create all the date formats you want, all the date hierarchies you want, all that would be MDX magic. Creating calculated fields on measures, that works as you know it, without the possibility of actually doing LODs. So that was a great plus for Paul. You cannot do LODs in cubes. And you cannot work with dimensions except for blended fields, as you have seen. But the MDX magic is you can create calculated members with measures, and dimensions and all of that together in MDX. You can create table calculations, just as you know it. That is something great, but you can actually create the same thing in MDX if you want to do it. Of course, there is a certain skill level involved in that. So, the usual, let's call them business users, probably wouldn't write MDX on its own, would probably more use the table calculations. But who has, the knowledge, can write MDX, can do more robust and, better calculations with the MDX magic. Grouping is only possible with MDX, unfortunately, and actually now creating new measures or new measure or new members within dimension. All of that is also only possible with MDX. And actually we are already, and I have to look a little bit on the clock. We only have 5 minutes left, don't we? 5 minutes. Well, great. Then we don't have time for any questions. Very good. So we are far into the second half. Obviously, so therefore there's some more stuff that we want to teach you about all of that, and that's again like Paul, right?
It's actually my favorite hockey quote that does work, but slightly more relevant to my life at the moment is this one. Okay, so we've talked about OLAP. They're not all created equally. So the sources that we support, we have to actively support each different OLAP source independently. We support SAP BW. We support SQL Server Analysis Services, Teradata, and wow, that's small. Essbase. Oracle is huge. Essbase is tiny, but it says Essbase there. We don't have, and this is just a driver thing, we don't have support for cube sources on Macs, unfortunately, all you Apple fans. So there's a list of differences. We've kind of tried to cover as many of them as we could over the course of this. Not available, it's mostly restrictions rather than additions. Not available with OLAP sources, Tableau aliases. Our advanced analytics functionality, so things like trend lines don't work on cubes. User-defined hierarchies don't. They have to be baked into the cube. We lose the flexibility as soon as we put that rigid cube structure in place. Aggregation, so you can't change the aggregation type. That again is defined in the cube. We expect to retrieve the value, not calculate it. Groups and bins don't work except where you can create them through MDX. Extracts don't work, with the caveat that we added support for SAP BW to extract in 10.4 and above. And workbooks that use cube data sources cannot be published to Tableau online as it stands. And a lot of those basically come down to the fact that everything is pre-aggregated in the cube. The cube is a very rigid structure. I think I've said that about 27 times. And we've been through the calculations, the fact that you can do a lot of the kind of top-level calculations okay, but for anything particularly complicated, you have to start writing your own MDX so that the cube can do it for you. Table calculations, though, do work. We do those on the result set that we get passed back, so where that data originated actually doesn't really matter to us. When it comes to web editing, you can't actually start a web editing session directly from a cube, but you can web edit workbooks which have been published against cubes. So if you publish up a blank workbook with a cube embedded in it, then that's going to work. You can just allow people to edit that and then save as into another location. They'll be able to kind of work around it that way. All right, so we're just going to wrap up now. I think we're just about on time. Yeah, so we've got a little disclaimer here added by my friend over there who's very keen to highlight the differences with SAP BW. Not everything works in BW. That's mostly limitations from SAP's MDX processor. They haven't implemented things like CDate. The type conversions are limited. Everything is a hierarchy in SAP BW, so everything is anchored at a root node, which complicates some MDX functions that are supported, get a little bit more difficult to write. And yeah, there's a few other sort of functional differences there as well, but those are the big ones. But at least with SAP we can extract, and once you extract from SAP BW, then you're in a hyperfile, and that hyperfile is relational, and all of the functionality comes back that you're used to with Tableau. So that's a nice little value add. You're just eliminating the cube. I've not seen this version of the slide deck apparently. I feel like there's some kind of Infinity War joke there. Right. Good one. Yeah. So just in conclusion, basically, although Tableau clearly has all of its functionality against relational, some of it restricted against cubes, there are definitely use cases where a pre-aggregated model is better for performance, better for governance perhaps, and better for users who don't want to be worrying about writing complex business calculations. For instance, in financial world, they might just want all of that to be structured exactly as they are going to report it. And then a lot of the problems we have with reduced flexibility go away because people in those use cases aren't looking for flexibility, they want consistency. But yeah, with Tableau we can combine the best of both worlds. You can have a dashboard which contains from cube and relational, so it's the choice is yours at the end of the day. There are some resources out there. These links you will receive with the slide deck. So the OLAP training video is quite a nice place to start. We have all of the functional differences in one single list on a knowledge base article. And we have a nice kind of online focus for SAP BW specifically relating to how we extract from that, since we didn't cover it here. We were asked to include related sessions at the end of these. We are the only cube session, so go to a relational one that you'd like the sound of, I guess. And yeah, please, unless you absolutely hated this and you're going away fuming, do rate us in the app. And thank you very much for attending.